Okay, the first part of the chapter is about hypothesis testing, about the value of the population mean against a constant. Chapter 9. First of all, let me do some problems. I'm going to do problem number 1 on page 353, and it says the manager of Denver Hilton Resort Hotel stated that the main guest bill for a weekend is $600 or less. Okay, they claim that the mu is less or equal than $600. Okay, that is the claim. A member of the hotel accounting staff noticed that the total charges for guest bill have been increasing in recent months. The accountant will use a sample of weekend guest bills to test the manager claim. Okay, which form of the hypothesis should be used? Okay, so this is a claim. So what we would like to test, okay, or to prove is that the mean is greater than $600. So this is what we want to prove, and this has to go in the alternative hypothesis. So the correct formulation of this hypothesis is that the mu is greater than 600, and the alternative and the null hypothesis is less or equal than 600. Remember, always, the null hypothesis deals with the equal sign, so it has to be less or equal over here. Okay. Okay. Now, let's do the hypothesis testing for mu when sigma is known. Okay. We are dealing with a C, the standard normal distribution, and we are dealing with the test value. What is the test value? The test value for this one has to be x bar minus mu 0, and mu 0 is the constant that we are testing our parameter against, divided by, since we know the standard deviation of the population, divided by sigma over square root of n, and again, n is my sample size. And then after I get the test value, I'm going to compare with the critical values that I already should have calculated. Okay, so let's do one problem. Let's do problem number 9. Problem number 9 says that the hypothesis, the null hypothesis is the mu is greater or equal than 20 against that is less than 20, the alternative. Okay, first of all, in this case, we already have the formulation of the hypothesis. The next thing that we have to do is to find out if this is a two-tailed or a one-tailed test. In this case, only when the null hypothesis is equal, we have a two-tail. In this case, we do not have a two-tail, we have a one-tail. Now, the null is greater or equal and the alternative is less, so in this case, we have a lower tail test. Okay, that's it. That's the first thing that I need to know, to find out what type of test we are dealing with. Okay, later on C they said that alpha is equal to 0.05, so this is 0.05. This is alpha, okay? So we are dealing with a 95% confidence level, and we are using the C standard normal distribution. No. Now, what is the value over here that is my critical value that divides the rejection zone from the fail to reject zone. Okay, be very careful on this because we are dealing with one-tailed test. So this is 0.05. It's not negative 196. Okay, this is a negative 1.645. This is my critical value. And check your numbers from the previous chapter from confidence interval. When we have an alpha of 0.05, or when we have a tail of 0.05, the value is 1.645 negative. And if you go to the tables, you can see that as well. Okay, so that's it. We now have the type of test. We have the critical value. What we need to do is to make the computation of the test value. And according with the formula is X bar. Okay, I need more information. On top of 368 says a sample of 50, so my N is equal to 50. Provide a sample mean X bar, that is my sample mean, 19.4. And the population standard deviation sigma is equal to 2. Okay, so this data is needed to compute the test statistic. And the test statistic is X bar. What is X bar? 19.4. Minus mu zero. Mu zero, remember, is the constant that we are comparing our population parameter against. So it has to be 20 divided by sigma 2 over square root of 50. And that is equal to negative 2.12. Okay, so that is the value of my test. Now, if we are using, okay, let's do this the both way. The critical value approach and the p-value approach. Now, if we are dealing with the critical value approach, we are going to identify where is this negative 2.12. Okay? Since this is negative 1.64, my 2.12 is going to be here. Let me use another color. This is the point 2.12, negative 2.12. As you can see, this value is in the rejection zone. The rejection zone always is in the shaded area. So we reject the null hypothesis and we conclude that we have statistical evidence to support that the mean is really less than 20. So we have evidence in favor of the alternative hypothesis, or in favor that the mean really is less than 20, with a significant level of 0.05. Now, let's use the critical value approach. Okay, the p-value approach. Once you have your test value, you are going to identify this area over here, to the left of your test value. So, to the left of negative 2.12, and that is your p-value. Okay, so go to the table and check 2.12, and that value is 0.0170. That is your p-value. Now, what has to be the conclusion? If 0.0170 is less than 0.05, that is the value of your alpha, 0.05, then we reject. Is that right? Of course, 0.01 is less than 0.05, so our conclusion is reject the null hypothesis, and we reject, in both cases, we reject the null hypothesis. So we are doing, doesn't matter which route you use, through the critical value or through the p-value, the conclusion has to be exactly the same.